Hey, miss me? It's Johnny. Let's talk about titanium. Many of the objects, Kiss Buddha excluded, on the table here, are made from titanium. I love Thai. I just want to say, for the record, if I could wife Thai, I would. I've worked with Thai extensively. I've made jewelry, knives, tools. Oh, wait. Look, it's a brass and titanium screwdriver that I've made. Anyway, I want to talk about sort of like ideal material characteristics versus how it gets implemented. I want to talk about what makes Thai so goddamn beautiful and just show off some cool shit. So, let's begin, shall we? Number one of my most carried knives. It's a Benchmade that I got in a knife trade. I can't remember the number. Benchmade uses these stupid numbers for all of their knives. It's like BM 40 something or whatever. But it's got a jeweled titanium liners and what used to be a very deep blue titanium pocket clip. Yeah, I mean, I like butterfly knives even though I'm shit at flipping them. And this one, because it's so small and has a little pocket clip, even though it's fucking illegal and I shouldn't be carrying it around as a responsible citizen of the great piece of shit state of Washington, I still will carry it. I have cop friends, very few actually. Surprise, surprise, I've got very few cop friends. But anyway, I've asked them what the deal is with carrying illegal knives, and they said, dude, don't worry about it. If you were like high on crack and like stumbling around the street and we see a pocket clip or like a fixed blade tucked to your belt, we're going to use that as a tool to stop you, but we're not necessarily going to like pull over a law-abiding citizen, especially one who's rational and reasonable, and also, you know, only mildly brown, unfortunately, just because you have a knife that looks quasi-illegal. So, yeah, titanium, beautiful. It's fairly easy to heat anodize. So what that means is that rather than using an anodizing process like you would for aluminum, which is where you're sort of like shocking the structure of the surface of the metal and actually dyeing it, you're actually encapsulating the color into the metal. What you're doing with titanium, well, I mean, there's a couple different ways to anodize Thai. You can electro-anodize it, which is great. It's from my experience with it, it's longer lasting, and you're able to really control the spectrum of colors that you achieve with it. But the cheap and dirty way is to just hit that shit with a torch. So here's this little scrap piece I was making something out of. You see we go from almost a white to sort of a straw yellow. So depending on how hot you get the piece of titanium, you'll have a different color result. So basically, rather than dye, what you're doing with alloys like titanium and niobium, and there's a bunch of them like that, and even steel will behave like this to a certain degree. You are actually growing or depositing an oxide layer, so it's basically oxidizing and rusting, and heat accelerates that. And the thickness of that layer refracts light of different frequencies, right? So you're like blasting this with a torch, and initially it won't be doing anything, and then you'll see that it'll start to, this straw wheat color will sort of creep in, and then it'll go gold, and then it'll sort of switch to purple, and then it'll go even deeper like indigo, and then it'll go light blue, and then it'll go all the way around again back to sort of whitish silver. So if you can get yourself some titanium, play with it. It's very forgiving, and it's really strong. I mean, this has been bent, then straightened, then bent, then straightened, heated to thousands of degrees over and over again, ground, filed. Like, I've really worked on this chunk of Thai, and it is still stiffer and more resistant to bending than a correspondingly thick piece of steel or aluminum. So, really fun stuff to play with. It's easy to get Thai scraps if you know where to look. Hint, hint, a lot of old forsaken bicycle components are made from Thai that you can play with. So we have also a very very nice titanium spring for a sort of coil-over shock. It's still a giant chunk of metal, so it's heavy. I don't know what alloy they use for this, but it's still a nice big chunk of tie. If it doesn't get used in a bike project, I'll probably cut it up and make rings out of it, or like slave choker chains. Who knows? Speaking of titanium alloys, the two most common ones that you're going to see are called 6-4 and 325. And so what they are is they are an amalgamation of different metallic components creating what is called an alloy. So an alloy is a mix of several different varying levels of metallic elements, and they are tuning them for certain properties, right? So they might want it to be less brittle, or they might want it to be have more tensile strength, or they might want it to be more heat resistant, or they might want it to be really hard. And so you can fine-tune pretty much any metal, all the aluminums that we use in bicycles, all the titaniums, all the steels, they're all alloyed with something. They're not just plain. So in both cases, 6-4 and 325, the first number is referring to the aluminum content. So 6% aluminum, 4% vanadium. The second number is vanadium. So 6-4 is 6% aluminum, 4% vanadium. 325 is 3% aluminum, 2.5% vanadium. Generally, you'll find that 6-4 stuff is a little bit more rare. It's harder to work with, so it just destroys tools. Like, if you ever tried to cut 6-4, I guess it must work harden really quickly, and it just starts blowing teeth out of saws and just destroying files and stuff. So you break a lot of drill bits, your taps get fucked up. So what I've heard from friends who build frames is that they would rather work with 325 because it's more forgiving on the tools. It's also cheaper, and honestly, the ride quality on a 325 bike is pretty dope. 6-4 tends to be, from my experience, I've had both types of bikes, and I can't say that this is 100% scientific because they've all had different tube diameters and different layouts. You know, one was a mountain bike, one's a cyclocross bike, one has a 2.5-inch diameter down tube, one doesn't. However, it seems to me that the 6-4 stuff feels a lot stiffer. It feels much more close to like an oversized aluminum frame than it does to like a steel frame or a traditional tie frame. So here is a titanium bolt-on skewer, basically. I had a titanium cassette, which honestly, like, I should just use it because it's cool, but what I end up doing instead is making like wind chimes and decorations after anodizing them. So yeah. Now these two are sort of interesting. There was a time in sort of the late 90s, mid 90s sort of era where a lot of people were attempting to make titanium bottom brackets. Now, that's not that big of a deal. I guess titanium would sort of work for this application, but the problem that you see with all of these designs is it doesn't lend itself very well to square taper. So if I wanted to make a really strong titanium spindle in bottom bracket, I don't think it would be a problem at all to make a 24 millimeter or 22 millimeter or even 30 millimeter hollow titanium tube like you would see on a modern bicycle. And I'm talking something that would fit in either a Shimano Holotech 2 or perhaps a BB30 or PF30 or any of that garbage. By the way, press fit is garbage. And even the nice bottom brackets you can put in, like Praxis Works, are just fucking workarounds. So I'm glad to see some of the bigger companies moving back towards external cable routing and threaded bottom brackets. I'm so happy to see those two things. So what do we have here? This is a Samson, right? And just off the top of my head, people who are making tie bottom brackets at this time period were like, Samson was this one. This is an Ericsson. Philwood I think they may even still make one. Even older than these, we had ones made by Campagnolo. We had Zeus, which is like a Spanish Campagnolo knockoff company. Boone, most famous titanium man outside of Jeff Jones. Boone, Boone, beautiful titanium stuff. They had this titanium bottom bracket that was twisted, like it was a helix in the center, and it was oversized just as this one is. And Hope made a titanium bottom bracket, and there are dozens of other ones. You know, this is the era of the little tiny mom and pop. I own a mill, therefore I'm going to build some cool parts sort of business of mountain bike component manufacture. So, yeah, I think you could do it with modern stuff. Simple parts, you know, nice, thin walls, large, oversized tubes. You could totally make like a Dura-Ace crank with a 2018 Dura-Ace crank with a titanium spindle. It would work just fine. However, these are notorious for cracking. I have personally seen them crack. I have actually had a titanium fillwood crack, so has my friend Justin. Now, those guys are great. They just warrantied it, you know, no questions asked. Although they did suggest that perhaps we might replace them with stainless steel ones, which of course we did. You know, how much weight are you saving? Not much is the answer. So, what they're doing, and this is, I have these two examples because they're two different approaches to a problem that would be solved by re-engineering everything from the crank to the bottom bracket. You know, what they're trying to do is they're trying to use a superior material. Arguably, I mean, I think that steel, like Shimano still uses currently, is a superior material. However, arguably a superior material, but they're mating it to something that is antiquated and old, right? The square taper, 2-degree taper, sort of wedge interface is antiquated, and so you're using the wrong material for the application. So there's stiffness issues. It's not as stiff as steel. And also, it's a little bit more fragile, which is, you know, it's counterintuitive, but it's, you know, I don't know the material sheet on the alloys of titanium they were using, but the way, when these fail, the way that I see the cracks propagate and sort of the failure modes that I get to see with my own eyes, they look a lot more like aluminum than they do like steel, honestly. So this piece here was a big bar. It was just a giant, huge bar of titanium. It's had some surface treatment. It's been anodized, sort of that gold color. Perhaps it's been heat treated for strength. It could be that they took it up to a certain temperature and held it there to get this sort of straw yellow color. But unfortunately, seeing this really sharp transition in this shoulder, which is usually where bottom brackets like this break, and you got cartridge bearings in there. It's very thick material. You know, you can't see how they fluted it here, right? So you can't get inside of this and machine out the inside to make it hollow. So much like the hollow cranks that we were looking at the other day, they've taken material from the outside to lighten this, and it's not light. Like it's not particularly light. You want light and stiff and strong. The solution in cycling, and probably in engineering in general, is you get the tube to be as large as possible with the thinnest walls, as big and as thin as makes sense. You don't want it to be susceptible to denting, and you don't want it to be so big that it can no longer fit into the item that you're trying to stick it through. But, you know, we've seen now in the area of ever-increasing bottom bracket or crank spindle sizes, and ever-decreasing wall thicknesses, that is the answer. You want light and stiff. That is how you have to do it. However, here we are. Old tech meets new materials. The one that I find just awesome, and that came in the other day on a buy, this looks normal, right? It's got a little dust cover in the middle. You know, initially, so one, I'd never seen a tie bottom bracket quite like this, and I didn't know who the maker was. It took a little bit of research, but it's a company called Ericsson. I don't think it's the Ericsson, the frame builder from up in Seattle. I think it's the European Ericsson. I think they're frame maker and makes parts, but information was dicey at best. Anywho, what happens when we pull these off? Their construction method, although reportedly these also fail like every single time, still, the idea behind this, I think, is much more sound. And this is actually light. Unlike this, and unlike the Fillwood that I owned, this is light. This is light enough to be an actual weight savings that would mean something on a bicycle. Do you see what they've done? So they've taken small pieces of bar, starting here, and they have milled the square taper spindle. They've made 2 of them. Then they've taken a tube, a very thin-walled tube made of titanium, and carefully welded the 2 machined bits to the tube. So this is actually hollow. This is actually thin and hollow, and I love the little touches. I don't know if you can read that. Scribed into it, it says Lot 8. They were obviously making very small batches of these. This particular one is not cracked, and it came with Italian cups as well as English cups. But, you know, we march into this bold future, or maybe we boldly march into this dismal future, but this was the nicest implementation, aside from Boone, which is all like good luck getting your hands on that. This was the nicest implementation of a titanium bottom bracket I had ever seen. Nice sealed cartridge bearings. Nice protective dust cover that fits perfectly. And what's nice is it's not just a sleeve. It's a complex part. It has matching relieved areas there, plus a little lip here, and it clicks into place. And it's actually creating quite a nice seal. So, man, there were all kinds of titanium gabagools kicking around in the 90s. They had titanium crank bolts, so you could have tie crank bolts for your titanium bottom bracket. Although those came with big fucking warnings that said, do not install the cranks with these bolts. So what you were supposed to do, because the tie was more fragile and couldn't take that initial setup torque, is you'd install your cranks to the correct torque using steel or chromed or whatever crank bolts that were supplied with your bottom bracket or cranks. Then, once they were torqued fully, you would remove those bolts because the cranks had already been pressed on to a wedging fit, and then you would replace them with the titanium bolts. So, you know, they've learned a lot about manufacturing and working with titanium. I don't know if you remember the first sort of commercially viable titanium bars were done by Titech, and then there were some made, I believe, still by Titech that were branded Bontrager. They were not bulge bars. This is what's crazy about them. They were ultra thin. And so, you know, a bulge bar is what's very common. Most handlebars are like this, where you have your, let's say it's a mountain bike bar, you have your 7/8 inch or 22.2 diameter for the controls and for the grips, and then where it enters the stem, it's actually been formed so that it bulges up in the middle and then comes back down. And that bulge is where you clamp your stem. Before bulge bars, you would see what are called ferruled bars, right? So you have a ferrule, which is just like this metal tube, and you slide it along your handlebar before it's bent into a drop bar or bent into a riser bar. You put this ferrule on, and you know you probably crimp it on or epoxy it, or it's aluminum, so you're not brazing it. So bulge bars are just the way it's done. But you know, the early titanium ones, even in an era where every single mountain bike bar was a bulge bar, the first titanium bars were just plain tubing. You just had 7/8 inch tubing with maybe 0.7 millimeter wall thickness, and they would be sort of shaped into the shape of a mountain bike handlebar. And then what they would do is that they came with a nylon, like a glass reinforced nylon. It wasn't just plain nylon. Shim. So the shim would bring the handlebar clamp diameter to 25.4, and that would protect this ultra fragile, ultra light handlebar, as well as fix the problem that they couldn't manipulate the titanium into that bulged shape. So tie is tasty. I mean, I've had titanium Chris King headsets, titanium track bikes. There have been tie bits on almost every component you can think of on my bicycles, from stems to bars to I was about to say rims, but that was just a pipe dream. That was an opium fantasy that I could have acquired the who made those? Arai? No? well, whatever. There was a titanium rim that was very awesome. I'm just rambling at this point because I am super hopped up on caffeine. But I did want to just say, I like Ty. Ty is my buddy. My wedding ring that I no longer wear, for obvious reasons, was made of titanium, and so was the old lady's. I don't know if they're ever going to reintroduce titanium, titanium cranks, titanium bottom bracket spindles. I sort of lumped them together because in 2018, a titanium bottom bracket spindle would be attached to the crank. That's how we do things now. But I would love to see more Ty parts. You know, I know that you can make it lighter and better with aluminum and carbon fiber. I get it. But those are dead materials, all right? If you get a chance, go to your local metal depot and hold some raw titanium bar. It has a warmth to it. It has soul. I really do think that steel and titanium, says the guy who rode here on an aluminum bike tonight, but I really do think that titanium has some soul to it. I really love the material. Yeah, I would love to see more comments on these videos. You know, even if they're antagonistic ones. I really want to improve this channel. Currently, I'm researching recording equipment and editing equipment. You know, I have this like old i5 ThinkPad, and I was simply not able to get most modern video editing suites to work on it. I mean, I could do dumb stuff, like I could take a GoPro or the phone and I could record clean, you know, video of what I'm doing, and then I could do a voiceover. That's totally doable. But, you know, time is limited. I really want an efficient machine to do that. And yeah, share these videos. I was thinking that an untapped market would be Reddit. I don't know anything about Reddit's bicycle community, but I know that the rest of the community are just the craziest rabid nerds, and that, I mean that in sort of a good way. So yeah, if you are active in any of those communities, shout me out. It's a wonderful evening. The sun has finally gone down. I've put my shirt on. That's how you know it's quitting time. So yeah, have a wonderful night. Yellow Sheldon signing out.